Hello and welcome back. This is going to be a brief video. It's a follow-up to the 120 amp hour battery video that I put up a while back. If you remember, we were using a ZEVA Zero Emission Vehicles Australia Battery Management System. It's a CAN bus system and it has a color touchscreen disconnected right in the front panel of the battery. That's all well and good. The problem is you have to be standing right next to the battery to see anything. So in considering that problem, I did a little bit of research and found out that you could get a CAN hat for a Raspberry Pi. So I'm going to run out in the garage and show you what I did. This is a streaming data. It's CAN bus data. It's streaming at 4 Hertz. It's being intercepted by a Raspberry Pi 3B Plus with a Pican Duo hat on it. It's on the network and I've logged in using remote desktop. Unfortunately, this data is pretty much useless. I can stop it, take a screenshot, and you can convert all the hex data into real numbers, knowing what the CAN address is for the battery voltages, etc., but that's kind of the hard way to do it. So I wanted to find a way to convert this data into something meaningful that you could just view inside at your office without having to stand next to the battery. This is a Raspberry Pi with a Pican Duo CAN bus hat. It's basically intercepting the CAN bus signal from the ZEVA BMS, and it's transmitting it via Ethernet and the switch here onto the network, and that's what I'm picking up inside with the WebSockets. I'm using this remote desktop to remote into this Raspberry. I put an ad out on Craigslist and somebody from Texas responded. He's an electronics engineer and also does some programming gigs. He set up a WebSocket service that would intercept streaming CAN bus data and serve it up to a web page. Now the WebSocket server is started, and this is the client side, or the web page that receives the data and displays it. The PicanDuo does have a CAN send feature where theoretically we could put values in and change the menu settings on the ZEVA. The problem is it doesn't broadcast the menu data out to the color touchscreen or anywhere else, so you can't keep track of it. It's in a non-volatile memory in both the BMS and the color touchscreen, so once you use the touchscreen to change something, it's memorized there, but it's not updated if you change it via any other method. So at this time, this is only a monitoring situation where I can see the voltages, current, power, temperature, state of charge, all of that. The only reason there's menu settings on the bottom of the screen is those are used to draw the number of cells that are being used, the pack capacity, so you can calculate the state of charge and percentage, these kinds of things. So for now we're just going to have to leave it. And if you notice, the screen does jump a little bit. I had to set up an automatic screen refresh program. The reason is the rendering is so slow. I think they call it layout thrashing. In any case, the page becomes unresponsive, so about every 50 seconds I just refresh the page and it keeps it going. So not a perfect solution, certainly not a commercially viable product, but it certainly works, and I can log in anytime I want and see what's going on with the battery. Although you can't see it now, what's interesting, when the active cell balancer kicks in, you can see the voltages change on the voltage bars, and you can see which cells are being charged and which cells are being discharged.